So good morning, dear students. Am I audible?
Yes, sir. Good morning, sir.
Thank you, Arpita, for the confirmation. We shall start today's class. So today we have on the agenda two components. One is replica replacement, how Hadoop name node will replace will place replicas, and what strategy it follows. Second one is coherent model that have been followed in Hadoop distributed file system. So that's about today's class objective. Let's move on to the first point. Yesterday we have seen, okay, this model. In this model, actually, we write data into the various data nodes using pipeline of data nodes. So whenever a set of data nodes are been chosen by your name node, so your FS data output stream will certainly write those contents into data nodes one by one as a pipeline. Okay, and finally, once everything is written, the final acknowledgement will be sent back to the FS data output stream. Finally, the same FS data output stream, which is residing inside the Java virtual machine of HDFS client, will send a message to name node stating that it is the entire operation is complete. Okay, this is the overall scenario yesterday we discussed. Now, the question is how your name node is actually the master. How the name node will decide, okay, or will choose data nodes to store replicas. So this is what the main question generally it comes to our mind. The point being thought of here is, so normally what happens, there is a trade-off between reliability to write the bandwidth and also read bandwidth. Normally read bandwidth, you don't require much for reading the data. You don't require much bandwidth because you will be reading only from a single data node. Okay, and the single block, single data node. If there are multiple blocks, so whichever the block the data node has, only that connection needs to be activated, and you have to read it. So there also you have to follow same data node pipeline. But while writing data into the data nodes, you have to consider different data nodes for each block, and you have to follow replication factor of 3, which is default. And so data node involvement while writing the data is more. So definitely the bandwidth. So the bandwidth chosen for writing the data, the bandwidth required for reading the data is less compared to bandwidth for writing the data. So with this consideration, so the same thing, for example, placing all replicas on a single node, maybe incur lowest bandwidth. Okay, lowest. If you write many replicas in the same data node, of course, you may encounter less bandwidth. But what is the main purpose of replication? The main purpose of replication is, if that particular data node fails, so you should get it. You should be able to get it from the other places. So if all replicas are stored in the same data node, no matter, of course, you can say the bandwidth, but do you really offer reliability? It is not the case. So what happens? Your name node will choose in such a way that the replicas are not stored in the same data node. It will be definitely stored in different places. So let us see what are the other points. Okay. Also, the read bandwidth is high for off-rack reads at other extreme placing replicas at different data centers. The maximum redundancy, but at the cost of bandwidth. Okay, definitely. So if you put in different rack, if you put in different data nodes, so cost may be more, but you can certainly achieve, replication. You can certainly give reliability. You can certainly give fault tolerance. So that is what, the main basic idea about consideration while you are placing the replica, So that is one very important thing. So even the same data center, there are variety of placement strategies. Okay. So you know very well, a data center is a collection of many racks. So it is just like a library. Okay, in library, you have many racks, and each rack, you have many books. And each book you just imagine each book is a computer. Each book is a data node. Okay, so like this. Instead of storing the data in a single data node, you can choose different data nodes because of reliability policy. So if the entire data node fails, okay, gone. All replicas, whatever you have kept, also gone. So there is no use of having replication at all. Simply, it is a waste of space. But if you keep it in different data nodes, yes, definitely yes. If one data node fails, it can fetch from other data node. And the choosing of the second data node is another question here. Whether we have to choose in the same rack or in different rack. So it is always better. Okay. So considering the bandwidth utilization, because if you keep the data in a different rack, what happens? You have to spend extra bandwidth in order to reroute that to a different rack and different data node. You have to reroute, and it will be another delay process. It will be a costly, again, costly in the sense in the terms of bandwidth. Yes, no matter. But in the same rack, if you keep it in different data node, of course, you can reduce that, you can reduce that cost. Of course, normally it will be done in the same way. The secondary copy will be kept in different data node in the same rack. Different data node in the same rack. And the third copy is kept in different rack. Why different rack? Because if the entire rack fails, what happens? Even though your primary data node is also gone, the secondary data node also is gone because they are residing in the same rack. So what happens if the entire rack, this entire rack is failed? So gone, 2 copies have failed. So better you keep it in different rack. So if you keep it in different rack, it's another level of security. Even though it is costly, no problem. We'll have at least 1 copy in different rack. It's good. So to have a different rack, this concept we call it as rack awareness. What is rack awareness? Rack awareness is nothing but it is the storing of data in different data nodes of different rack just to avoid from rack failure. So when rack fails, entire data nodes, all the data nodes in the rack fails. So even if you keep replication in the entire rack, in different rack, different different data nodes in the same rack, so gone, your replication is gone. So that is the concept that we have to consider. Hadoop default strategy is to place the first replica on the same node, of course, the same rack you will have. And the second replica will be placed in different rack from the first off rack. It is chosen at random. Okay, so it will choose different rack randomly. It will choose. Okay, second replica, and the third replica is placed in the same rack as the second, but on a different node. So first copy here only, second copy on the different rack, third copy on the same rack but in a different option. Further replicas are placed on random nodes on the cluster, although the system tried to avoid placing too many replicas on the same rack. So this is very, very important, this concept. So placing the data on the same rack is avoided many times. So it will be definitely written in different racks, and understand. So if it is so important, user can configure, the admin can configure, it can be kept in different data centers. So if you keep it in different data centers, replicas, of course it has to connect to different data center, different rack, different data node. Only thing is the time. If you store it in different data center, definitely it will consume some time. Okay, it will not be as fast as the local rack or local data node. So definitely it is a remote location. When you are storing data in remote location, definitely it will take different rack, it will take time, different rack, different data center, definitely it will take time. But that time, consumption of time, the consumption of bandwidth is more, so obviously the cost will be more. So you can certainly take a decision whether you will keep in the same data center or you can keep it in other data center. So normally nobody will keep in different data center unless it is too important data, very, very important data. Even if you keep it in different data centers, another issue arises, that is a security issue. Okay, if you keep it in different data center, so you will be worried whether the data of your data node, which you have kept it in different data center, is it safe? So, and many privacy issues will come, a lot of issues will come. But if really admin wants to store it in different data centers, he can certainly store it in different data center. It's not a problem. But 90%, so this model will be followed. What is this model? The first copy is kept in the same data node, and the second copy is kept in different rack, and third copy is kept in the different the same rack of the different data node. So this concept, it will not store in the same rack. This concept we call it as rack awareness, and it has been asked many times. Once the rack replica locations are have been chosen, the pipeline is built. So this is pipeline is very important. Pipeline is always, it is just like a linked list. The first copy and the second copy, the third copy are linked together. Linked together in the sense, the first copy has the information about the second copy. Second copy will have the information about the third copy. All these information as a pipeline, it will be stored in the name node along with the file name entry. Okay, and once the replica location has been chosen, the pipeline is built taking network topology into account for a replica factor of 3. So you can certainly increase the replica factor, you can decrease the replica factor, and all these information, it is stored like a tree, linked list tree in your name node. So have an opportunity to see all those things. So it is looking like a tree, beautiful architecture. Name node is built. Okay, anyhow, next, that's about replica placement. Replica placement, mainly it is done because we need to provide reliable service. So whatever the file you store, it should be available at any cost. So it is replica is required, and replica is placed on different data nodes, different racks, sometimes different locations. So this is to avoid entire data node failure, entire rack failure, entire data center failure. So just to understand all these things, certainly it has been followed. Now, other operations like listing of all the files. Programmatically, in your Java program, you can certainly write this method. So list status method. If you just write the list status method, what happens? It will list all the files that are there in that particular path. And if the path is not existing, or if it is not accessible, certainly it will generate a input-output error. Next, we have deleting data. Deleting data, use delete method. So use delete method on file system to permanently remove the files or directories. Of course, delete method can be certainly done. And here F is the path, and along with this you need a Boolean value, recursive, true or false. If you set it as true, what happens? If the path is a directory, all its subdirectories, all its files, everything will be deleted. If it is not recursive, only that file or only that directory will be removed. And remember, in order to remove the file, there is no restriction. In order to remove a directory with recursion is false, so what happens? You generally make that directory empty, and you can delete it. Normally, observe, if the path contains file, so recursive will be false. If path contains directory, then recursive will be true. Or else you certainly give, you will certainly experience IO exception. So that is, that is the consideration. Same thing it is written here. You can just see if F is a file or an empty directory, then recursive is ignored. A non-empty directory is only deleted along with its contents if the recursive is true. Otherwise, you will get a IO exception. So this is very common. Two functions that two methods that are being used in your program in order to handle the files. Next, coherence model. What is coherency model? Coherency is nothing but it's a file system that describes the data visibility. Who can view, who can read your data, who can write your data, etc. The file visibility, component, the permission component, we call it as coherency model. And of course, you can certainly, give permission. You can give permission by using assert that. There is a method called assert that. So when you say assert that, what happens? That particular copy, okay, will be given a permission for the external viewer to use that file. If you set it as false, you can certainly deny from visibility. Even the file is listed, you cannot read that file or you cannot write into the file. So you can do that using this coherency model. And however, any content written to the file is not guaranteed to visible, and even if the stream is flushed. So a file appear to have have a zero, length of 0. Okay, so how to check that? So you just check whether is 0 length, so long. If it is that, then you can certainly assert. So you can give the permission. So that's what. Once more than a block worth of data has been written, first block will be visible to the new readers. And of course, this is true subsequent blocks. If the permission is given for first block, then subsequent blocks are also given the same permission. So that is second block also you can read, second, third block also you can read, and you can do. It is always the current block being written that is not visible to other readers. So normally, it is also, so if somebody is writing into the block, so it is not being visible to others. So in order to avoid this, we have a sync method. So sync method is just like that. What happens? It maintains a synchronous. If somebody is writing, so it will display. Okay, somebody is writing, you can certainly see. See, normally you will experience this if you are working with Google Docs. Okay, some document you have opened, and some other people are also opened the same document, and simultaneously many people are writing. So you'll easily understand there is a corner box. So who is writing, who is watching, who is not using, all those information you can see. So that is what is the result of the sync method. So HDFS provides a method for forcing all the buffers to be synchronized to the data nodes via sync method using FS data output stream. And of course, after successful return from sync, HDFS guarantees that the data written up to that point of the file is persisted and visible to all the readers, new readers. So it can be done like this. Before you flush the data from your stream, data output stream, certainly you can sync. So if you sync, what happens? Even though you maintain 3 replication, 4 replication, all the replications are synced. Only then it will be flushed. Okay, and later you can give assert. So assert that certainly that method you can certainly use. So assert that method will always certainly give the permission for the users, new users, to use that particular block. Okay, so for that you need a sync. Okay, same way you can also do by closing the file. HDFS performs an input string. So sync method is required. Sync method, look at here, sync method is required whenever your connection is open. That means your output stream connection is still open, you can certainly, exclusively you can do, explicitly you can do, or exclusively you can do synchronization among all the data nodes or among all the blocks of data. But if you close, look at here in this example, if you close the file, automatically all the data blocks parallelly written or replicated data blocks are all synced in the sense they will have the same content. Then only they are allowed to use assert that. They are used to use assert that method. So assert that method will certainly, give permission for viewers, permission for new users to read, write, and do operations on that particular file block. So this is what you call it as coherency model. So this coherency model has implication for the way you design an application. So with no calls to sync, whether you want to call a sync or you don't want to call a sync, so you should be prepared to use up the blocks of data in the event of client or system failure. So this is what you have. So I think the last component is a parallel copying with a dist copy. There is a function called, there is a command called dist copy, distcp. So what is this is doing? So anyhow, you have already specified the replication factor. So you have given the file to the HDFS client. Client will talk to your name node. Name node will give list of data nodes and along with the replication factor. So the HDFS access these patterns that we have seen so far, focus on single thread access. But when you are doing with the dist copy, distcp, so that means parallel copying. So parallelly, if you are using replication factors, so definitely what happens, parallelly they are copied. So it's possible to act on a collection of files by specifying so a file globs global lobs. For example, for an efficient, in order to make efficient parallel processing of these files, would have to write a program yourself. And remember, here we make use of multi-threading concept. The concept that you have learned in previous semesters, multi-threading concept in Java, so that will come here. So this multi-threads will certainly work parallelly in order to handle each copy. So each single thread will handle one copy. So if you are maintaining 3 copies, 3 threads are using. If you are using 2 threads, that means 2 replication factor. 2 copies are being manipulated. Hadoop comes with a useful program called distcp for copying a large amount of data and of course large amount of data to the HDFS systems or from HDFS system in parallel. Of course, parallel copying, parallel writing is done using this CP. So the canonical use of this distcp is for transferring the data between 2 HDFS clusters. So you can see this information. If the clusters are running identical versions of a Hadoop, of course, remember one very important, distcp works pretty well even with different versions of Hadoop. Yes, that is another, even if it is different versions. That means in one machine you have Hadoop 1.0, in another machine you have Hadoop 2.0. Yes, it works. So if it is working with the identical version, yes, then it is very easy. Of course, you can see. And this will copy the foo directory. Of course, remember foo directory and bar directory. So first cluster to bar directory, and of course second cluster, so that it is, if a bar does not exist, it will create automatically. If the first level is not there, it will create the automatically second. Okay. So by default, distcp will skip the files that are already existing in the destination. And remember, very important, file cannot be overwritten. File cannot be overwritten in HDFS, because we know the policy. Write once and read many times. You don't have the option for overwriting, or you don't have the option to update. Only you can create, or you can insert. That's all. You cannot have the option to overwrite. But they can be overwritten by applying overwrite option. So this is advanced setting option available only in Hadoop 2.0. Overwrite option is available. So when you have overwrite option, it is it is the concept that what it is doing is it will delete the existing copy. Then in the place of a deleted copy, it will place. That's all. So in Hadoop 1.0, overwrite is not available. Okay, right. You can also update only files that have been changed using update option. So update option, again, the old contents are removed and new contents are just put. Of course, you can see Hadoop distcp update. So what is the content? Name node 1, foo, name node 1, name node 2. So bar foo. So what happens simultaneously, the contents been updated. So from one data to another data, one data node to another data node. So there is one name node to another name node. Automatically the data gets updated, of course. Distcp with MapReduce. MapReduce also uses a distcp. So distcp is implemented as a MapReduce job. So we'll understand what is this MapReduce in the next module. Of course, tomorrow I'll complete this module 4, and day after tomorrow we'll start. That is on Monday or Tuesday. We'll start next week onwards module 5. So in module 5 we'll discuss in detail about MapReduce. So where you have the copying is done like a map function, and parallelly across the clusters, and of course there is no reducers are required for this. And of course -m would certainly require 1000 maps. So maps are nothing but parallel processing components. We'll discuss that. So map is a parallel processing component. So if you are if you try to use distcp between two HDFS clusters that are running in different versions, the copy will fail if you use HDFS protocol, since the RPC, remote procedure call systems, are incompatible. So to remedy to this, you can certainly use read-only HTTP based on HFTP. So Hadoop file transfer protocol file system to read from the source, and of course you can copy it. You can see that Hadoop distcp HFTP. So HDFS protocol is not used. It is used with HFTP. Suppose it is having a different protocol, and you observe here there is a different port ID. So you are reading this, you are directly copying the file. So from parallelly to this and to this. So which is there in name node 1. Name node 1 runs on different Hadoop version, normally Hadoop 1.0. So whenever you have this 570 is Hadoop 1.0. and this is actually Hadoop 2.0. And of course, using newer, and apart from this, you also have another protocol called Web HDF. So, which will certainly, it is a replacement for HFTP. It is possible to use HTTP for both the source and destination clusters without hitting any wire incompatibilities problems. Because certainly you can see. So instead of writing HFTP, HDFS, you can certainly write HDFS, web HDFS. So it will certainly work. So this is parallelly you can copy. Okay, so that's all for today's class. In the next class, we'll discuss about how to keep a cluster balanced, and also we discuss about what is the compression technique that is being followed in Hadoop. So that we will discuss in the upcoming class. That's all. Thank you for attending. Have a wonderful day. The entire class video is available in this website, and it is actually a YouTube channel. Okay, I have used. Kindly, you can subscribe. You can watch. So whenever you are reading the notes, if you get some doubts, you can certainly go to those videos. You can refer. The study material is available in this particular website. So that's all for today's class. So thank you. So we'll discuss keeping Hadoop cluster in the next class. Thank you. That's all for today's class.